In this video, I'm going to talk about autoboxing. Autoboxing is a concept that allows us to convert between primitives and object corresponding types. But before we even go that deep, let's go back and talk a little bit about primitives. Before we talked about primitives, the main primitives that we know are int, chars, long, float, doubles, booleans, byte, and a few others. Okay, so those are our primitive variables, right? These primitives here represent variable types that aren't objects, okay? They are in their most primitive form. Because Java is indeed an evolved language, they also included the corresponding object types of all of these primitives, meaning in Java, we can also have integers as such, right? We can have char or characters, and notice that when we are getting the corresponding type in object form, it's now characters. So you have to spell it all out as such. And you notice we also have uppercase first letters, okay? Again, long, float, doubles, byte, and so forth. Okay, so these are the corresponding object types instead of the primitive. Now, let's do a little exercise here. Let's say I have an integer called I, and I give this 32. Let me go ahead and create an array list here. Let's say array list. I'm going to go ahead and just call this my array is equal to new array list. Instantiating an array list, we name this my array. So the array list, we can go ahead and invoke and say dot add. We can go ahead and add, for instance, our I that we just received, that we just created at the top here. Okay, so far so good. Notice something. If I go ahead and say my array, now notice something. If I want to retrieve the item that I've just inserted into my array list here, I would say, for instance, int my item, let's say, is equal to, I'm going to get my array invocation here. I'm going to say dot get. I'm going to pass the index. In this case, I know exactly everything the number is going to be inside of index 0. And all of a sudden, we run into an issue here. Let's hover over and say, it says here incompatible types required int found object. So it seems, now if you hover over and click on this red bulb here, you notice it says cast to int. So what's happening here is internally, this array list is actually saving everything as an object, meaning it's saving this number 32 here not as an integer because it really can't. It's saving it automatically as an integer type or as an integer object type. Okay, that's the reason why when we say int my item, this is going to be obviously the int type. It's saying, well, the variable is an integer. However, what we're getting here is indeed an object of type integer. That's the reason why if you go ahead here and say cast, now we are saying, well, we want to convert this integer, right? Uppercase integer, as we see here, the object corresponding type of the int primitive into an actual primitive. Then all of this works. Now, the beauty of having autoboxing is that this whole process here happens automatically. So we won't need to cast anything, meaning for that to work, we are going to add here the type integer in our Angular brackets. Okay, so we're now saying our array list will receive integers, objects. And you notice the moment you do that, then you have no problem, right? We don't have to cast anymore because autoboxing happens automatically. Okay, so the moment we specify the types that we are passing, then autoboxing happens automatically. The other way we could have done this, we could have, for instance, say int b is equal to 23 as such. And for instance, if we wanted to wrap or to make this integer b here into an actual object integer, we could have said the following. We could have said integer. Notice we're going to create an integer object here. I'm going to call this my int. Let's call this my object. And then I would say is equal to new integer, right? I'm calling the integer class here, constructor, and I'm going to pass b as such. Now what this does, my object now is going to be of type integer, but integer as an object. So this is no longer a primitive, right? Because we took this integer and we wrap it. So here, what I'm doing, I'm physically wrapping my int primitive variable. Okay, so this process is automatically being done when we just pass in an integer as such. Okay, so now if we go back here and for instance you want to say int recover int, I can just say my object int value. So what happens now, I went back and unwrapped my object back to integer. Okay, so here I'm unwrapping the integer object that I just created here. So now this recover int is back to b, which is just an integer, a primitive integer that is. Perfect. And obviously you can do the same with any other type. For instance, if you have a char, we can create here a char and say char, my char is equal to d as such. Okay, and if I wanted to go ahead and use the same concept here, I can say character as such, my character. I can go ahead and say new character, and what I do, I pass my char. So here I'm indeed wrapping my char here, my character, my char of a primitive char into an actual character object. Okay, so I'm transforming it, I'm wrapping it. Okay, and of course I would do, if I wanted to unwrap again, I would just do the same. I would go back down here and say int recover char is equal to my char that char value. You notice we now have the char value, we have int value, and you could imagine now all these methods, right? We can also get the same methods in other types, long, float, double, booleans, and so forth. The reason why this is very important is as we start building complex programs, there will be times when we want to be able to autobox or convert or wrap or unwrap certain primitives into objects of the same type or vice versa. So then you have this capability, you have this way of getting that job done. Okay, for instance, you have 23, as you can see here, as an int. You want to make it an integer, right, as a type object, so that you may want to do something with it. You are very welcome. You can very well do that. So now we're looking at ways in which we can use that flexibility that Java gives us with objects with our primitive variables. Okay, so that's huge. So this concept is a very important one because, as you can see, we again get a lot of flexibility in terms of converting types from primitives to objects. All right, I'll see you next.